Welcome back after a long break, class 10th. Now I am going to start the second chapter of electricity, that is the magnetic effect of electric current. And the previous chapter we have discussed the heating effect of current, electric current. Now we are going to discuss about the magnetic effect of electric current. So before starting it, we have to show some property of magnetism which is given by some bar magnet or natural magnet, you can say. So first of all, the science of magnetism is developed from a ore which have the property to attract the iron bit of iron and some directional property. It means when you suspend it in freely direction, it will direct it towards the north to south. And the second property, it attract the iron like materials. Now some story behind the magnetism is that the magnet was first discovered in the city of western Turkey, that is called the Manisa. On that time it was called the magnesia. Magnesia, due to the name of magnesia, it is called the magnetite. Actually this ore is a oxide of iron that is given by Fe3O4. Fe3O4, it is the structural formula of this magnetite. Now later on in 1600, Dr. William Gilbert also discovered that earth is also a property of a magnet. Here I have suspended a small bar magnet through the thread, and you can see it is directed towards the north and south. This direction is north and this is south. When we just disturb the bar magnet, then automatically it moved to the same direction, north and south. We cannot handle it in the different direction. You can see when I push it in direction of east and west, then it will automatically change the direction towards north and south. You can see here it is moving towards north and south. So it is the directional property of this bar magnet. Also an example of natural magnet. And some more property of the magnet. Before it, I want to say that the magnet is of some kind of magnets are there. First of all is the bar magnet that I will show in a video, which show the direction property of the magnet. And magnet needle, it is actually in the rhombus shape, it used to detect the direction. And the third is the compass needle. Compass needle is also used to detect the direction in different field. Now it is also an experimental use in class 10th. And another magnet is horseshoe magnet. It is also used in different experiment. Now we are going to discuss about the magnetic line of forces and magnetic field. What is the magnetic field? Magnetic field is a space where the property of attraction and repulsion started around the compass. Here you can see bar magnet is placed just below to this paper, and this iron filling has a shape of virtual line of forces. You can see here it is starting from north pole and move toward the south pole. So this type of shape will show the feed line, the magnetic feed line. It is shown by the iron fillings, and in the second experiment we will use the compass to draw the line of forces, magnetic line of forces. The magnetic line of forces, these are the virtual line of forces around the magnet. We can show it with the help of a bar magnet. Suppose that I am taking this north pole and south pole of the magnet, and the second experiment, first experiment I have already shown in the video. In the second experiment, first you will keep a compass here, and the compass needle, the arrow of the compass needle showed where put a dot, and the back of that is towards the north. You know it is the north pole, therefore it is away from the north pole. Now just keep this compass needle from here and keep it here, then the needle will move this direction. In the same way you can produce so many dots. After the completing this complete way, you have a line and the direction of this line is here. Similarly, you can draw different lines in your experiment and the direction of these line of forces from north to south, but here it is not given. The inside the magnet, the direction of magnetic field is south to north. Okay, so these are called the magnetic line of forces. Now I am going to discuss some different property of the magnetic field lines. It is all, these are also called the magnetic field lines. So you know very well, these are the property of magnetic field lines. A magnetic field line is detected from north pole to south pole outside the magnet. A magnetic field line is a closed and continuous curve. We have not shown magnetic field line inside the magnet where these are directed from south pole to north pole. The third property is the magnetic field lines are crowded near the pole where the magnetic field is strong and are far apart near a middle of the magnet and far from the magnet where the magnetic field is weak. The fourth property is the magnetic field line intersect each other because if they do so, there would be two direction of magnetic field at that point, which is absurd. It means, suppose that the line of forces intersecting each other, then there will be two direction and it is impossible to have the two direction at a single point of the magnetic field. Now the fifth property is, in case of the field lines are parallel and equidistant, these represent the uniform magnetic field. The Earth's magnetic field is uniform in a limited space, and some tips are also I am going to here give you on your tips. These tips are given in front of you, you can note it down and it is very useful for you. There are 6 points. A natural magnet is a piece of the iron ore magnetite Fe3O4 which has property of attracting certain other substances like iron filings. Points in the north-south direction when suspended freely. This phenomena is possessing attractive and directive property is known as the magnetism. A natural magnet is also called the lodestone. The second property, second tips is, pieces of iron or other materials made magnets by rubbing with the natural magnets or by passing direct current through a wire wood around them are called the artificial magnet. A compass needle is a small pointed magnet. Its end point north is called the north pole while other is called the south pole. The place in a magnet where is its attractive power is maximum are called the poles, while the place of minimum attractive power is called the neutral region. Like poles repel each other, whereas the unlike poles attract each other. Poles always exit in pair. So some properties like that are given, you can note it down.